All right, so we are now talking about another piece of key features, which is continuity. Now, inside of this continuity, we'll be talking about a thing called limits, and just an introduction, not necessarily actually go into, not even an introduction, but just to show it to you, to see kind of like what it's used for, and then in calculus, you go more in depth with it. So continuity is what we're looking at right now. So we're talking about continuity meaning continuous functions. Is it continuous? Is it not continuous? So here's the definition for continuous functions. So continuous functions are functions that go on without holes or gaps. So it goes on forever and ever and never, doesn't stop, just goes, 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 goes. And there's no holes, there's no gaps, there's nothing to stop it from actually being continuous. Now, what we're going to deal with in here in this lesson is talk about if a function is continuous at a certain spot. With that, we should be able to look at the value they give us, and we'll have some steps that we can go through to actually talk about whether it's continuous or not. So that's what we're going to work on. So before we go there, though, we know that continuous functions, again, like we said, goes on forever. But what about the opposite of that? What is continuous functions not? What is pretty much the opposite of continuous functions? That is discontinuity. That's the opposite of continuous. It's discontinuous because it's not continuous. All right, so when we do that, there are three different types of discontinuity that we're going to talk about. So so there's three of them, and we're going to talk about all three of them. When you get to calculus, you'll talk about this more and actually do some other stuff with it and everything too. And we will talk about different pieces of it as we go along, and as we have different functions and require you to do different things with those functions. All right, so with that, again, there are three different types. The first type is considered infinite discontinuity. We call that infinite discontinuity because it just goes up forever and ever and ever. And wherever this line is, wherever they go, that's where the discontinuity is going to happen. But we never have that line, or we never know what that is because it goes on forever to infinity, because that's where we have arrows going on forever. So therefore, we have infinite discontinuity because it goes up forever, it goes down forever. But also, whenever you have infinite discontinuity, you're always going to have an asymptote, a vertical asymptote there. So if we're looking at as x approaches 0 or whatever, we would know that there's infinite discontinuity because it's going up forever, it does not stop. Okay, the second type is your jump discontinuity. And for the first one there, that is a rational function, what we've been talking about, the lesson before this. The jump discontinuity. We have a piecewise function here, and we've talked about piecewise functions too, and how to graph those. So if you look at it, the function comes here, it stops at this point, and then it jumps to this point here, and it continues on. So with that, that's what a jump discontinuity is. It starts here, it starts at some point, it stops there, and then it jumps to the next function, and it goes on. So jump discontinuity. Our last one deals with something that we've talked about already, rational functions. And this is talking about a point discontinuity, which again, that's a rational function there. But as you notice, there is a hole in the graph right there. There is a hole. And we know with holes, that means that if we were to factor out the numerator, we would get x plus 1, x minus 1. And so at x plus 1 there, that means that we would cancel those out because there's one on top, one on bottom. So technically, we're looking at the function x minus 1, which is what's been graphed there. But when we talk about our vertical and horizontal asymptotes, our vertical asymptote, we set that equal to 0, x plus 1. We get x equals -1. So, -1, sorry. And we normally said, okay, that was our vertical asymptote. But technically, because factors cancel out, there's actually a hole at x equals -1. So with that, we're talking about here a hole in the graph, or point discontinuity. So this is back on talking about what we did when it came to our rational functions. Holes in the graphs, rational functions. Point discontinuity. All right, so we're going to go to example 1 here, and we're going to talk about a graph and actually point out all the pieces that are discontinuous, and we're going to label them of what they are. All right, so there we go.